In this recording, we're going to learn about log form and how it relates to exponential form. Now, you already had an introduction with that. Let's continue. You can write these notes on the back of your intro to log sheet. So, we asked before, what is a logarithm? A log, for short. Now that you're well acquainted with it, you can call it by its nickname, log. Okay, and we said basically it's an exponent. Okay, and that's one way to describe a log. It's an exponent. Okay, another way to describe it is it's a function. Okay, just like square root is a function that gets rid of square, log is a function that isolates an exponent. Okay, so let's consider this function. Y equals 2 to the x is an exponential function. You're familiar with it. Okay. The inverse. We haven't talked about inverse in a while. Let's talk about inverse. Okay. So the inverse of this function, well, we have to switch x and y. Well, this doesn't have the y isolated, so what we can do is now rewrite this in log form. So when we write a log equation, we can start with log, and a log always needs a base. So what's the base here? Well, the base is the same thing that has an exponent, right? So 2 is the base, so that's small and down. Log base 2. We said log is the exponent, so the y is the exponent. All right, so that's what the log is equal to. And the argument of the log goes right here. So log base 2 of x equals y. Pretty cool. Okay? That's the inverse. I'm going to move that down right in this space. All right? Log base 2 of x equals y is the inverse of this exponential function. Okay? Now, it's really handy to be able to switch back and forth comfortably between log and exponential form. So, if you have an equation like this, y equals b to the x, and you have an equation like this, log base b of y equals x, we need to be comfortable knowing what the parts are. Okay? So, b, well, let's label that first. We know that's the base. Okay? The base of an exponential function is the expression that has the exponent. So that's easy. The base of a log is what's written small and down, if it happens to be written. Okay? This is the exponent. And the exponent is equal to the log. All right, what the log is equal to. You know that's an exponent because it's written up in the superscript, right? Top right. This is what the log is equal to because it says it's equal to log. All right, and finally, well, if you can get those two pieces in place, you've got it. This thing here is called the power, right? B to the x is the power, or whatever that is. And this over here, this y, this is called the argument of the log. You do not need to know that word. I only bring it up here so that you recognize that there is a name for it if you ever wanted to name it. But the two critical pieces are to know what the base is and to know that the log is the exponent. Then you're going to get the third piece to just fall into place. So if we've got that, let's see if we can solve the equation that we posed before. We have this equation. We don't want to guess and check. Can you write an equivalent log equation that would isolate x and allow us to just pop this into our calculator? Play the recording when you've written a log equation that's equal to this. Okay, so hopefully you started with the word log. And you asked yourself, well, a log needs a base. What's the base? Well, the base is what is being raised to an exponent. So it's log base 4. Now the log is the exponent, so that's what the log is equal to. So log base 4 of 10 equals x. Pretty cool. Let's hop over to the calculator. We'll go log base 4 of 10. There's our answer. Now to confirm that, let's raise 4 to the exponent of that number. Cursor up and paste it. And sure enough, it comes out really, really close to 10. So we know that that number is the approximate exponent, the logarithm of 4, base 10. Let me get that right. I'm going to try one more time. This number here, what does it represent? It represents the logarithm, base 4 of 10, the number we raised 4 to get a 10. If I wanted to round this to the nearest hundredth, I would just simply write 1.66, and let's do that here. X is approximately equal to 1.66, or however many decimal places I choose to have. Thanks for watching.